So, my dear students, again we are going to meet with another one more problem of different one. Here I have taken a symmetric matrix now this time. So, as usual, I have written the question as find the eigenvalues and eigenvectors of the matrix A equal to first row is 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. As you know very well that no need to discuss about what is symmetric and non-symmetric, because you see that A equal to A transpose. So that's why we are taken it as a symmetric matrix. Okay. So next one is we are going to find out here based on that, as usual, the characteristic equation. So the characteristic equation is determinant A minus lambda is equal to 0. As usual, along the diagonal, main diagonal, subtract lambda. So 6 minus lambda, 3 minus lambda, 3 minus lambda. The remaining elements you write as it is minus 2 2 minus 2 minus 1 2 minus 1. This is equal to the characteristic equation lambda cube minus s1 into lambda square plus s2 into lambda minus s3. Now by shortcut method you can write this coefficient s1, s2 and s3 as the following elements. That is, s1 is equal to the sum of the leading diagonal elements, and your s2 is nothing but sum of the minors of the leading diagonal elements, and your s3 is nothing but a determinant value. Okay. So based on that, first let me start with the s1. So your s1 is, you have to add 6 minus 3 and 3. Okay. So these three elements you need to add. So I have added that 6 3 3, so it's equal to 12. Next one, for s2, as usual you have to go for finding that leading diagonal element minus. So it's 3 minus 1 minus 1 3. Okay. And next leading diagonal element is this 3. So you subtract the respective row and column, find out 6 2 2 and 3. And the next respective leading diagonal element is 3. So you just delete the respective row and column, 6 minus 2 minus 2 3. Okay. So the next one is we are going to calculate this value. So it's 3 into 3 9, 9 minus 1 plus 6 into 3 18, 18 minus 4, 6 into 3 18, 18 minus 4. So you got the answer as 36. Now S3 is the same. We are going to expand it by the determinant value. So determinant value also you have to be very careful, and you have to start with always plus first this value, then you have to concentrate in the middle value. Okay. Then you have to concentrate in the last value. Okay, the remaining. So you see that how I have taken the minor, minus 2 3 and 2 minus 1 I have taken. Is it clear? So after this you go for finding out the next one, that is S3. So calculate it. It is 9 into 9 minus of minus, it's 9 minus 1 8. So 8 into 6 you will get 48. Okay. So this value is 48, you will get. Next value is minus 6 plus 2. Okay, minus 6 plus 2 minus 4. So minus 4 into 2. So we'll get minus 8. So we'll get 48 minus 8. Then here it is minus 2 into minus 1 plus 2. 2 minus 6. So minus 4. So we'll get another minus 8 you will get. Okay. So get 48 minus 8 is 40. Again 40 minus 8 is 32. So you are getting this answer is 32. Okay. So now therefore your characteristic equation is lambda cube minus 12 lambda square, because we got 12, and minus it is because of minus alternatively plus minus plus minus. Then we have the second value is 36 lambda. Then this is already minus times constant term. So we got the constant term determinant value is 32. So minus 32 equal to 0. Now you go for finding by synthetic division. I told you already, you need to write the coefficients very carefully. If any of the coefficient is missed, don't forget to put at that place 0. So it is 1 minus 12, 36 and 32. Minus 32 I put. That is the coefficient of this characteristic equation. You see that how we do. So you substitute now the value here, then start to assign as usual, plus 1 and minus 1, plus 2 and minus 2, then plus 3 and minus 3. So I told you already that all the options you need to try. Okay. Now 2 suitably it suits the problem, so I substituted 2 and we got it as usual. Substitute 0 by synthetic, 1 plus 0 1, 1 into 2 2, 12 minus 12 plus 2 minus 10, 2 into minus 10 minus 20, 36 minus 20 you will get 16, 16 into 2 32. So the last portion you are getting 0, that's correct. Second one also, just by using this you try, and 2 is again suitable for this equation. So 1 0 0 we are putting by synthetic division, and 1 plus 0 1, 2 into 1 2, minus 10 plus 2 minus 8, 2 into minus 8 minus 16, 16 minus 16 0. So once if you are getting 0, that is a suitable value for factor for this equation. So as usual, lambda equal to 2, lambda equal to 2, lambda minus 8 equal to 0. I have written lambda equal to 2, 8. So lambda 1 is equal to 2, lambda 2 equal to 2, lambda 3 equal to 8. Here you see, observe that eigenvalues. 2 values are same and the third value is different. So automatically it is a different problem with the symmetric matrix. I have taken same eigenvalues, 2 same eigenvalues, one value is distinct. So in this case, how to find out that I have written here. To find the eigenvectors of these eigenvalues, first consider to find the eigenvector for the distinct eigenvalue. That means that this is the distinct eigenvalue. So automatically we need to consider first lambda 3 equal to 8. So I have considered always that lambda 1 is first eigenvalue is 8 only, and I started to find out my eigenvector. So it is a minus 8i into x1 is equal to 0. Along the diagonal we subtracted 6 minus 8, minus 2 2, minus 2 3 minus 8 minus 1, 2 minus 1 3 minus 8 into x1 x2 x3 is equal to 0. I have written all the equations, minus 2 x1 and plus 2 minus 2 x2 plus 2 x3. Here minus 2x1 minus 5x2 minus x3, 2x1 minus x2 minus 5x3 is equal to 0. First you need to analyze, whenever you are going to find out if you are getting a linear system, immediately you analyze whether the system is any two equations are same, or the system is having all the different non-identical equations or not. First you check it. So here all are not equal. So all the three are different. So as usual I have taken either first two equation or second and third, or you can take first and third also. So as usual I have taken second and third, and I have written the coefficients. You see that to find x1 I have started with the x2 coefficient minus 5 minus 1, minus 1 minus 5 here, minus 2 2, where you started you end with it. Okay. Now you cross multiply it. So it is x1 divided by 5 into 5 25, and minus 1 into minus 1 already plus 1 you will get, by minor you will get on minus 1, x2 divided by minus 2 minus 10, and x3 divided by 2 minus 10, 2 minus of minus plus 10, which is equal to k. So your x1 divided by 24, x2 divided by minus 12, and then x3 divided by 12, which is equal to k. So therefore x1 you are getting it as 24k minus 12k and 12k. So your x1 is equal to, now by taking k equal to very minimum value, it is 1 by 12. I have taken 2 minus 1, 1. So this is the eigenvalue vector for distinct, only distinct eigenvalue. Now we are going to analyze the same eigenvalues, that is lambda 2 equal to 2. So for that case, as usual, first you find out by making the equations. So along the diagonal I subtracted 2 2. So you got this equation, that's 4x1 minus 2x2 plus 2x3 equal to 0, 2x1 minus 2x1 plus x2 minus x3 equal to 0, 2x1 minus x2 plus x3 is equal to 0. If you observe that, all the three equations are same. So in that case, I told you in the previous problem only, you have to assume any one variable as 0 in the eigenvector. I assumed that as usual, first x1 is equal to 0 I put. See that. Okay, so I put x1 equal to 0. So putting x1 equal to 0 in any one of the equation, because all the three are same, you get minus x2 plus x3 equal to 0, minus x2 equal to minus x3, x2 equal to x3. So x2 and x3 are same. So you can give arbitrary choice for x3, which is the minimum value 1 you take. So already x1 we put 0, x3 we are substituting 1. So x2 will get 1 automatically, for x3 1. So your vector will be 0, 1, 1. Is it clear? So your second eigenvector for the same eigenvalue, first same eigenvalue, you got the vector as 0, 1, 1. Now we are going to apply now the next one is, we can't apply the same methodology what I applied in the non-symmetric matrix for the same eigenvalues. You can't assume the next vector is x2 equal to 0 and the next vector is x3 equal to 0. We can't. Okay, because one property it says that especially in the symmetric matrix, the third eigenvector, that means eigenvectors are mutually orthogonal to each other. That means that what is orthogonality is, when you can say the orthogonal matrix is, suppose if A is an orthogonal matrix, then A transpose A equal to A inverse A. That means it is equal to I. Okay, so it satisfies that whenever the symmetric matrix is given, the eigenvectors are mutually orthogonal to each other. So therefore, what I am going to do is I am going to apply this property A transpose A. So here I am going to apply for all the eigenvectors x1 transpose x3 is equal to 0, x2 transpose x3 is equal to 0, where x3 is we need to find out. That I assume it as ABC. So we need to find out. So I substituted with the x1 transpose as row vector. So row matrix it is. So we need to find out row matrix as, so row matrix as 2 minus 1 minus 1 into ABC is equal to 0. It is supposed to be x1, x2, x3 only, but we need to find out a new eigenvector to satisfy the orthogonal to each other. So we can't apply the same x1, x2, x3. Instead, you take ABC. So you'll get the reduced equation as 2a minus b plus c is equal to 0. You assume this equation as 3. Similarly, you take which a vector already we found x2. You take x2 transpose x3 equal to 0. So x2 is already 0, 1, 1. So I put it in a row vector, row matrix. Then ABC equal to 0 means 0 into A plus B, 1 into B plus 1 into C equal to 0. B plus C equal to 0 is third vector, third equation. So solving 2 and 3, you will get it as 2A minus B plus C equal to 0. B plus C equal to 0. So you will get the equation as 2A plus 2C. That means that, or 2A is equal to 2C you will get. That means A equal to C. Or other way of finding it is, you apply directly the cross multiplication method. So I have substituted all the coefficient, just I have taken where I need to. So we need to find out A means B coefficient, you write minus 1, 1, C coefficient write 1 and 1, A coefficient is 2 and 0, where you started you end with that. So it is A divided by minus 1 minus 1, it is minus 1 minus 1, then B divided by 0 minus 2, and C divided by 2 minus of minus 1. Sorry, 0 into minus 1 is 0, so 2 minus 0, 2 you will get it. So A by minus 2, B by minus 2, C by 2. So automatically you will get the answer as, you will get the answer like this. Actually, this is equal to K. So we'll get like this, minus 2K and minus 2K and 2K. Okay. So we are going to substitute here the minimum value of K is equal to 1 by 2. So therefore you will get minus 1 minus 1 1. So the eigenvectors are now, this is the third eigenvector. If you are checking it, all the three eigenvectors are orthogonal to each other. So you will get it the value as the answer as now x1 equal to 2 minus 1 1 and x2 is equal to 0 1 1. And for the same eigenvalue minus 1, we use orthogonality concept and we got the vector as x3 is equal to minus 1 minus 1 and 1. So with this the problem is ended, and we normally this is a different problem which I have not explained before. It is a symmetric matrix with the two same eigenvalues and only one eigenvalue is distinct from that of the other two, the same eigenvalues. So this is the methodology you have to find out the eigenvectors. So once again we will just go through that, the entire problem. So we'll start with the first one. It is a matrix, that's why I have written A into A transpose. A is equal to A transpose. It's a symmetric matrix. We got by shortcut method, we got that characteristic equation, we started to find out our eigenvector by using only the distinct eigenvalue. And same eigenvalue we assumed by same methodology what we applied in the previous problem, x1 equal to 0. Then you should not apply for the third vector the same methodology, because it is a symmetric matrix. Orthovectors are, there is eigenvectors are orthogonal to each other, so we'll go for the third eigenvector by making orthogonality, by using the method of orthogonality. Then we got that eigenvectors like this. So it's better you concentrate and try to understand it. Thank you.